Hello again, and welcome back to General Science. Last time, we talked about compounds and how they're made from different elements being combined together to become something new, something with new properties, new possibilities. Today, we're going to start talking about kind of how that works. Why are we able to take two different elements that are different, smash them together, and make something brand new with these new characteristics? In chemistry, we call that process of making a new compound a reaction, right? It's a reaction. So a reaction is when we take these two elements, or these two compounds, or whatever it is we're taking, and we put them together and do some stuff to them, and then they make something new. So what does that mean necessarily? Well, it means that to make these new compounds, to make new things, you have to be able to successfully complete a reaction, and you have to make sure that your reaction is actually making what you want it to make. And that's a lot of work. I spent hours in a chemistry lab at my university doing just that, and it was a lot. It's a lot to do. But it is really cool, the results when you end up making something brand new. Okay, so today we're going to talk a little bit about the general stuff around reactions, and then in the next video we'll start talking more about specifics. So to begin, we're going to start with kind of the very basics of reactions, and the first thing we need to talk about is that there's really two main groups of reactions. The first one is called an exothermic reaction. Now, an exothermic reaction is one that releases heat. When chemicals or elements are bonded together into compounds, they're really storing energy in those bonds, right? However it is they're bonding together, they're storing energy in them. And so to make something new, you have to break the bonds apart of whatever it is you've got and then reconfigure them into the new thing that you're going to be making. And sometimes, right, the amount of energy that was stored is more than the amount of energy is required to recreate the new thing you're trying to make. And so all this excess energy that you have is going to be released in some way, whether that be flame or heat or whatever, right? This energy is going to be released. Sometimes it's released as light, okay? So let's talk about some exothermic reactions you might be aware of. If you've ever used a hand warmer or a foot warmer during the winter when it's cold, those little packs, right, that you kind of push together and they start warming up. Those are exothermic reactions. There are two chemicals in those bags, and when you smash them to make them start to work, you're allowing the chemicals to come together and they release heat. And that heat is what you then use to warm your hands. And that's why eventually the hand warmers stop working. The two things that were reacting, they've run out. They're done with their reaction, and so they no longer produce heat. And that's an example of an exothermic reaction. Another, well, it's not necessarily exothermic, but another example of a reaction like that is the chemicals that are found in those glow sticks. When you crack the glow stick, right, and the color starts to come up, it's because the chemicals have intertwined and reacted with each other, and they produce light. That's the energy being released from this reaction. They've created a new compound, but they've also released some light, which is light is energy, if you didn't know that. Okay, so those are two examples of kind of an exothermic reaction. Now, on the other hand, we have what are called endothermic. Oops, did I forget? Uh-oh, hold on. I'm back. I was right, it is endothermic. Sometimes you gotta check. Can't know everything at once. It happens. So endothermic is then when the amount of energy needed ends up being more than what was originally in the contributants, the reactants, and energy is sucked in from the environment to make this new chemical. And so what happens then is things freeze up. They get cold to the touch. So the example of that, kind of opposite the hand warmers, are those instant ice packs that you might have gotten if you've ever gone to the nurse, right? And they had those little bags and they'd punch them and then they'd get really cold. Same idea. There's a bag inside the bag, believe it or not, right? With some chemicals in it. And on the outside, there's another chemical. And when you punch the bag, you're breaking that inner bag holding the chemical, and they react with each other. And because of the energy that needs to be sucked in to make that happen, it becomes really cold, and that's your ice pack. Right. So those are the two major kind of groups, right, of reactions. We've got exothermic, endothermic, one that releases energy and one that takes in energy to make it happen. Let's talk a little bit about why that is. Why does energy have to deal with this thing? Well, it turns out energy, right, is what causes all chemical processes to occur. And so, um, making sure that you have the amount of energy, the amount of reactants you need, is very important to chemical reactions generally. The other thing I wanted to talk about before we end this video that's kind of general in the term of reactions is that reactions have to happen in what's called a stable ratio. Okay, so when you're taking two things and you're making something new or whatever you're doing with your chemical reactions, there's a ratio into which these molecules will actually react with each other. So, for instance, a really common chemical equation you might have seen if you've taken any biology, is the one where we take sugar and process it into water and CO2. So if you take sugar, which is C6H12O6, 6 carbons, 12 hydrogens, 6 oxygens, and you react it with oxygen, you need 6 of those. They react, and you end up getting carbon dioxide and water out of that. Well, there's a specific ratio that reaction works in. And so if you're ever lacking in one of those things, the reaction can't continue forward, right? So if you don't have enough sugar to process into carbon dioxide and water, you're not going to be able to make that reaction happen. Same thing with the oxygen. If you start somehow losing oxygen, you're not taking in as much as you normally would, you're not going to be able to make that process happen anymore. An example that I'm familiar with, right, when it comes to that is when I run. Okay, so I'm a runner, and um, when you're running, you don't always necessarily take in as much oxygen as you're used to, especially when you're running really, really fast. Um, so let's say you're sprinting, right? You're dead sprint, running as fast, kind of like Usain Bolt, right? 100 meters as fast as you can. Okay. Now, for that first little bit, your body can keep up when you start to run that fast. You're getting enough oxygen, you can still continue to do the normal energy process for your body. But when the oxygen starts becoming limited, right, because you're breathing so hard, it's hard to breathe, you're struggling, right? You know what that feeling is, that tightness in your chest, because it's difficult to run, right, that fast. And so you're not getting all the oxygen that you're used to getting, right? Your body has to switch to a different energy creation method. And that's what makes your legs hurt and burn and your stomach feel all queasy. It's because it's doing the energy process that is not as natural to your body. And so it creates these byproducts that makes your body hurt, because it's like, stop doing what you're doing. You need to slow down so we can go back to what's normal. That's what your body wants, to be in the normal processes, right? So that's an example, right, of what's called a limiting reagent. A limiting reagent is something that stops a chemical reaction from happening because there's the least amount of it, right? In that example I gave, that example was oxygen, right? There wasn't enough oxygen, so the chemical reaction to make energy for your body couldn't continue. Therefore, it was the limiting reagent. Okay. Those are some basics about chemical reactions, just to kind of start us off on that journey. And then next time, we're going to start talking about the different types of chemical reactions, and then we'll slowly move into chemical equations, which kind of are our way of expressing chemical reactions with words and letters and numbers and whatnot. And then at the very end, I'll try to put together some demos for you. So we'll videotape me doing some actual chemical reactions, probably in my kitchen, because that's the space I've got right now, because it's winter and I'm kind of stuck in my house. So thank you again for watching General Science. We'll talk more about reactions soon, and I hope you learned something today. See you next time. Bye.